how many in here are new to the new Lexions for this year? So pretty much everybody. Okay. So I do have this presentation blends both green and yellow together, but there are a couple things that I need to point out on here before we go to the iron. And one of them will be on CBUS. Just as an awareness, you'll be getting a presentation, kind of a CBUS guide that takes you through the top 10 or 12 steps that you need to know on setting your CBUS up, because it is a different monitor than we've used in the past, and it's programmable. So much like most of the modern tractors and everything, like the Challenger over there, you got a lot of features available to control within those displays, but you got to program the screens to get those features up front. So I'll show you how to do a couple of those on here that'll make life a little easier. So anyway, we'll go ahead and get started. One of the first features you're going to notice on the combine, and probably most of you in here got them, is the new belt conveyor. Now, fundamentally, its performance is the same as the chain conveyor, with significantly less sound. So it's going to dampen itself. So it's going to be very quiet in the cab. You're not going to have the rattling that goes on that's characteristic of chains as they go around the drum, especially at high speeds. It's going to be much quieter. So right off the bat, you're not hardly going to notice the feeder house running when there's no head on the front. It's that quiet inside especially the new cab. But there are a couple of maintenance items that go along with having the belt. There's a little bit of a trade-off there, not much. But the primary difference between the two of them will be your first week of maintenance. So your belts they're going to stretch more than a chain will. So I recommend that about every other day, or if you even want to do it at the end of every day on the first week of operation, just make sure your belts are snugged up in the feeder house, because your top drive spokes are a little bit larger than the teeth that are used on a chain. And the lugs on the back side of the belts are kind of shallow. So we want to make sure that we get these belts right at especially in that first week when your initial belt stretch takes place. We want to account for that. And after that, after the first week, you should be good to go. And we'll talk about it in the iron, the procedure for doing it correctly. But that is the primary difference between the two. They both are going to convey the same amount of material. Just this one's going to do it much quieter, and the belts are much less sensitive to foreign objects out in the field. So if you do have if you are harvesting in a mineral-rich environment with some rocks, or you got some wood or other debris out there, a belt's breaking point is much higher than what a chain is. A chain can only go so much before it finally breaks, whereas the belt is going to go much higher. So that's why we get up to 2 times the life out of the belts versus the chains. So the life expectancy is double that of the chains. So that'll be a big plus. So, but the only downside, not any downside, but there is just a little bit more maintenance right up front. Just like any belt, your initial belt stretch takes place in the first week. We need to make sure we stay on top of that. We don't have the hydraulic cylinders anymore on the green combines like we had on the yellow combines sitting right over there. We went away with those. It actually takes some of the complexity away. As convenient as those hydraulic cylinders are, there's some little complexity with them. Required a little more maintenance to make sure they stayed phased, so they're both applying equal pressure. We don't have to worry about that on these. Now, we did make the access to the tensioners easier to use 2 wrenches on than what we had way back when prior to the hydraulic cylinders. So, but we'll look a little more of that when we get around the iron. Another thing you'll notice on here, we don't need any backup rings like we've talked about in the past, because the slats are much closer to the skin of the drum, so you're not going to need any backup rings. So speed-wise, so the other thing you're going to notice different on the new combine versus the yellow combine is the speed that is displayed. It is the same speed, but what we're displaying on the new combines is the back shaft speed on a header. So it's going to be displayed much faster. For example, the range on a 700 series was between 290 and 430, is now 510 to 740. 740 on this one is equal to 430 on that one. We're monitoring the speed from the exact same sensor on the top shaft. We're just displaying it as back shaft speed instead of top shaft speed. Back shaft speed is kind of the industry standard. That's why we did that. Everybody else displays a back shaft speed. We just decided to do that as well. We were being a little different here, so we decided to show that instead now. So no difference. When you got this wide open, just think of it as the same as what was on your yellow one before. 430 is equal to 740 or vice versa. So that'll be the one difference there. And just like the yellow combines, the tougher the crop, the faster I'll have my feeder house at, or the faster you're driving, you need to get that crop out of that header. So usually if it's tough green, I'm usually in the 80 to 100% of my speed, so I'll have it up there on the high end. In really dry, brittle conditions, I'll have it slowed down to a moderate speed, 50 to 70 or even 80%. So sometimes we don't need to run them wide open. So if you can idle them back a little bit, you'll be a little gentler on the crop, and things will run quieter as well. But you'll be the judge of that when traveling through the field. You'll know if you're driving too fast, you'll start pulling crop out of the ground. If you're pushing corn, you know you're going too slow, so speed it up a little bit so those corn stalks stay standing. Rarely do I go really slow. Sometimes we'll have to get down there in very dry, brittle conditions late in the season, but that's usually kind of rare. But if you have to get down in those lower speeds, don't hesitate to do it. You got enough conveying capacity in that combine, especially when conditions start to get dry, to handle lower speeds. And lower speeds is when that corn starts getting below 15%. If you do let it get that low. So, any questions on the feeder house? This is actually the belt right here, so you can see the large spoked wheels back here that are driving the belt, pushing the cogs around to drive that belt. I do have the master connect out front, so you can see how you splice it together. There are no maintenance patches you can put in there. If one belt is stretched longer than the others, you'll need to change them. Change all four of them out. There's no real easy way to cut out a section and bolt it back together. So we'll look at that too. You'll see that. So no half link, if you will, for the belts. So the feeder house drum. So running the drum up, you'll always hear me say that's the best place to run it, unless you've got rocks. And when you're harvesting soybeans, having the drum in the down position is probably the best way to protect against ingesting large rocks, because the feeder house slat will hit them and set off your slip clutch. Having it up is going to be gentler on the crop. When you've got your belts tensioned, that drum's pretty heavy, especially when it's got belt tension or chain tension on it. So it's going to put a lot of downforce in the crop, and we don't necessarily want that when we're harvesting a valuable crop, a delicate, valuable crop. So, and besides that, with the volume we're taking into combines, the whole reason why we put drums down to begin with many years ago is because combines were only that wide and headers were that wide, and you needed that down. You need that drum to be down to drag that crop in better. Today, this was 35-foot head. We're going up to 45-foot heads. You've got over 5-foot wide feeder house openings, and crop mat going into the feeder house this large or that tall. So having that drum up is really going to help out in the feeding efficiency of that combine. So I don't recommend putting the drum down for many crops unless you absolutely have to. But we will need to put the drum down though to when we're tensioning the feeder house belts or chains, and we'll talk about that over there in the combine. So another thing, this just popped up yesterday. I always have to remind everybody of this, is we had a field day yesterday up in Michigan, and they had the faceplate rolled all the way forward, and it makes it easier to pick that header up off the trailer. But when you're trying to get all that crop to feed back up inside that feeder house efficiently, it's kind of a challenge when that faceplate is all the way forward. By taking if this was your feeder house, here's the faceplate, you run it all the way forward, you've just increased the gap between the auger and the drum, so you're going to get some back feeding. So remember that if you roll your faceplate forward to get a little more reach to get that header off the trailer, make sure you bring it back to 0 to start. It'll feed a lot better that way. Otherwise, you might get a little back feeding in the beginning of the season if you don't. So that's the only thing I'll talk about on the faceplate. Otherwise, on this combine, we can set it to automatic. So it will alternate between different settings on this combine. You didn't have that on the yellow combines, but you now have that on this combine. Best results, again, are always having it set to 0, faceplate at 0. Sometimes in tough crop, I'll pull it back just a little bit, 1 degree or 2 degrees back to help it ride up over debris out in the field. With the Convio, I don't really have to worry about that because of the feature called Auto Flex and the 9 inches of vertical flex that we have on this cutter bar. So it's got a lot of flexibility. So it doesn't really need a lot of help. It helps itself out. So, and we'll look at one of the features on it when we walk over to the header. So, but on all Draper heads, one culprit that both increases wear and damage, wear on the combine, damage on the crop, is running those belts too fast. And I talk about this every year, and I always run across a couple folks out in the field that still have their belts running wide open and crowding the center of the combine. You know, when those rear impellers wore out on the yellow combines, oftentimes it was because you had the belts running too fast and making a really narrow, tight, dense windrow down the middle, basically focused on the center chains of your feeder house running down the middle. And that wears the center of the impeller out faster, slowing it down, getting the left and right to come in side by side in a V pattern, laying the left swath and the right swath down together. They were shallower and wider. You didn't have the hot spots on the inside of the combine, and the crop quality was better, and the overall efficiency of the crop flow was much better as well inside the combine. So so don't always go down there and screw that flow control valve wide open. Back it off a little bit. On the newer headers that have the indexed flow control valve, setting it on about 6 to 7 versus 9 or 10 really helps out. On this combine, you have the ability to adjust both side belts and center feed belt. Usually we have the center feed belt running a little faster than the side belts to quickly get that crop into the feeder house so it doesn't lag there in the middle. And then if you want, you can set that to automatic. And those belts, side belts and center feed belt, will adjust individually at a ratio of ground speed, just like your auto reel speed does. So as you speed up, the belts speed up. As you slow down, they'll slow down just like the reel does, to optimize that feeding into the feeder house based upon your ground speed. So, and that's an easy function to set in CBIS. Well, especially when you're into some really tough, high volume crop, it's nice to meter that into the feeder house a little better rather than crowding it into the feeder house when you get into some really dense, high volume crop. So the next one, we're moving back out of the feeder house into the disawning plates. Now, in addition to the disawning plates, we have another lever-operated blanking plate on this combine that will be of great benefit to you folks when you're cutting soybeans or going back into wheat next year. And it lies right under the main concave, the front section of the main concave. So your disawning plates are always a great tool to help improve threshing performance, especially if you're not using the exact grate that you should. For example, you've got round bar going into really tough green stem beans, and you don't want to have time to change the grates, so you don't have them, so just close the disawning plates up. But I really like to keep those disawning plates open as much as I can, because why? What happens up here in this, right up here in this area? One thing that nobody else does. Get rid of a lot of crop. Yeah, we have pre-separation that takes place. So anything that gets separated in the header, the feeder house, or by the action of this cylinder right here, that crop will fall through the pre-concave. Up to 30% of the crop can pass through here. So if you're doing, 1,200 bushel an hour of corn, or 4,000 bushel an hour of corn, you're going to drop 1,200 bushel through there in an hour. A little over a semi-truckload in an hour will pass through here. So in corn, we never close them. Soybeans, I try to be sparingly with that. I like to keep them open as much as I can unless I absolutely need them closed. But soybeans, that's one of the most delicate crops and one of the most value added, especially if it's a seed crop. So why not get more out up front? That bypasses threshing, goes right to cleaning, lets the threshing cylinder work on the tougher, more resilient crop, and get more focused threshing in there. So makes a much better grain quality sample. But if you have to close it, it's just lever operated, as everyone here knows. So it's almost too easy not to use it sometimes. But just remember that when you do close it, you lose that 30% pre-separation. Corn, it's necessary. Soybeans, you've got enough capacity here to handle, but if you've got a lot of dry beans out there that are popping open, let those go through here and free this up, maybe to push a little harder. If you're getting 30% out of the way here, that frees up more area underneath the threshing cylinder where you might be able to push the combine a little harder, be a little more productive. So then right underneath here, underneath this area, is another blanking plate that we can close down. And it can either be done manually, or it can be done from the cab, or automatically if you auto thresh on your combine. So CMOS auto threshing will automatically close and open that cover plate here on the front section of the main concave as needed when harvesting small grains or soybeans. It will not close in corn, but will close in beans and wheat. You also get a intensive threshing segment that goes with that as well. And it'll also engage and disengage in small grains as needed when using auto threshing. So that's where the hydraulic portion comes in. But if you don't get auto threshing, you still have that lever operated. So you got a rotary handle on the side of the combine where you can close it down. We still have the same APS grates that we've always used. In fact, the APS grates that you used in the yellow combines will fit in this combine here. So all the new 8000 and 7000 series, the frame and the APS cylinder diameter are the same dimensions as they always have been. What did change was the threshing cylinder went from 24 inches to 30 inches, and the rear impeller went from 18 inches to 24 inches. So the rear impeller in this combine is now as large as the threshing cylinder was in the 700 series. So that's going to give you a lot more inertia in here. It's going to let you do a lot more in low range. I don't think anybody threshed soybeans last year or the year before in high range. Everybody did it in low range. So oftentimes using settings that would be very comparable to corn settings, 250 to 300 on the threshing cylinder for doing soybeans. So that really results in a high quality grain sample. And that was how we achieved the quality that we did when we did our soybean test a couple years ago. So you do have the option, if necessary, or if you want to change the front section of your concave out, main concave out, you can do that. This combine is full round bar, so round bar in the back, round bar in the front section, and it's got the round bar pre-concave grates in it already. If somebody was going to do a lot of wheat, several, maybe 1,000 or so acres of wheat, you might opt to pull the round bar out and go with a wire grate if you want. But what we've learned over the last couple years with having these combines in the field with full round bar, it's amazing what you can do with round bar, especially with the larger threshing area that we've got now, 6 inches longer because of the larger diameter. That round bar is performing very similarly to large wire. So we've got combines that are harvesting all over from Kansas to Nebraska, east, and wheat, all round bar. Even not only soft red, but also hard red out there as well. So, which oftentimes requires a little assistance with some more wire grates up front. But they might be changing these out to 10 or 12 millimeter to get some key stock. But back here, it's all round bar, and they're doing very well. So the round bar, while it looks very gentle, it can be very aggressive. And very effective in soybeans, as we've proven even on the 700 series and the 500 series. So, but you do have the flexibility of changing that if you want. It's much easier on the tracks because it'll slide right out over the tracks. The wheels, you'll have to knock the duals off to get it out of there. But the odds of needing to change that so much around here, corn, soybeans, you'll leave that round bar in there and probably won't change it at all. So there are the different grates. Everybody's familiar with the grates. You've all got a couple of these, I'm sure. The top two are more for Well, the top left one, that's your 10 millimeter wire. This one right here is your smooth 6 millimeter. You won't be utilizing that one. These are the two soybean grates, the wire and the 12 mil grate right there. The difference between the two of them, well, the wire is a little bit more aggressive because the wires sit lower between the key stock than what they do on this one. Perforation size is nominal, so your throughput will be very similar. This one can be a little more aggressive because the wires sit lower, and that allows for a little bit more action up there in the pre-concave area. So this would be more ideal for small grains such as wheat or bearded wheat. This one I'd opt for soybeans, but if you've got this already in tough green stem beans, go ahead and use the 10 millimeter. It'll be just fine. So round bar, everybody's got round bar. We've been promoting that heavy for several years now, very successfully. That's a rice grate, and there's your old corn grate right there. So very, very dry conditions. I sometimes get complaints from folks about getting those pencil-sized pieces of stalk in the grain tank. And believe it or not, they're usually about that long, about as long as the section of a pre-concave, the gap. So sometimes you will get that thinner, drier stalk that breaks off and it'll roll through the bars. If you're getting a lot of that and struggling to get that out of the tank and you don't really want to return anything more, you don't want to lose any capacity there, that's a good time to use those old corn grates, those old smooth corn grates, because you're not going to get the pencil-sized pieces passing through this gap right here. You'll just make it under the threshing cylinder and grind them right up, and you probably won't find them anymore, or a much lower volume of those in the tank. So every once in a while I'll still use those just to get those pieces out. That's especially late in the season. Corn's 15–16%. The tops are starting to break out. You're getting more trash in the corn head. These will help keep those pieces from going in the grain tank with the corn grates. So if you've still got some of those lingering around from the 400 or 500 days, they'll still work right inside that combine. Any questions on APS grates? I get occasionally folks will ask me, what's the one grate that works for everything? Well, around here it'll be the round bar, very effective in beans, but I'll find myself occasionally closing the disawning plates down in those tougher pods to get those hauled open. If not, they'll pass right on through and might get in the grain tank. So, or you'll have to run your bottom sieve tighter to get them threshed back out or re-threshed. So, but that is the one grate the one go-to grate for both corn and soybeans.
In higher moisture corn, your pick would be the round bar.
Yep, round bar. Late season, very dry corn. Actually, it's not so much the corn, it's the plant. I'll use these in. And every once in a while, we have used those where you get into a condition where that cob just likes to break up and fall apart and leave kernels on it. Really soft, spongy cobs. I have been known to use these before, or recommend these just to get the key stock action on here. Just remember that once you get out of that condition, you'll want to change those out because these grates don't have quite the capacity that this grate or this grate has. If you don't have those and you do get into that condition where those ears just fall apart and kernels are all over them, sometimes closing the disawning plates here will help that out. You might have to run the concave a little wider, but you're getting more crop on crop action, trying to get as much of those kernels off without damaging the cob anymore and allowing cob chunks to go out the back of the combine with kernels still on it. So that is the only time I would run my disawning plates closed in corn, and you might have to pull back on the stick just a little bit because you did reduce some capacity by closing the disawning plates off right there. But the trade-off is it's going in the tank and not on the ground, and that's really what we want. So, and versus grinding it all up and turning it to white powder out the back of the combine. So there's the 6.5 smooth slotted for small grains. That does come with the small grain kit if anybody ordered one with that. There's the 6.5 with key stock that we don't use in this region. That's more for small grains. There's that 10 millimeter. Most of you have that one. The wires sit lower between the flat straps versus the 12 millimeter. So a little bit shallower in here. This is kind of my go-to for soybeans if you've got it. There's your corn grate. It was standard on all combines up until a few years ago. And there's your round bar. So, like I said, you can get some pods that pass through here. If you're running those in really tough green stems, just close your disawning plates as needed, and then try to make sure you open them back up when conditions start to get easier to thresh or drier. And then again in corn, that pencil size is about the length of that gap right there, and those top pieces of the stalk will roll right down in there, and you might find them in the grain tank. That's when I drop those in there to keep those from passing through there, and just roll on under the cylinder where it'll dispose of them in there. So, but there again, there's a shot of that intensive threshing segment if you have auto threshing. There's a shot of that cover plate and the handle to open and close it on the left side. There's your disawning plates that have always been on the combine, lever operated. Great convenient items to have when needed, that really get the uptime going because you don't have to stop and change any grates if you've got them in there. Unless conditions are really tough, then you have to change the grates. So on this one, so on high and low, we've made some big changes here. So this is the picture I always showed from the 700 series with the placement of the bolts, the reduction bolts, when we shift between high and low. We no longer do that on this combine. That's all done from the cab on this combine. So we no longer have to utilize the bolts. And with the larger diameter cylinders, like I said before, we find ourselves threshing in soybeans using nearly corn settings. So we'll be down in this area. Whereas on the 700 series, when we started getting slower and slower on the high range, we'd have to drop down in the low range to get that torque back because you'd start losing the torque. Something you don't have to worry about on this new combine anymore, especially with the large diameter cylinders and the inertia they provide, and that allows you to run in low range. So again, I can't think of anyone, unless they just wanted to try it, thresh beans in high range. Even the folks that were doing organics were still in low range and doing a really good job. So something to be said to going 30 inches in diameter with a cylinder. That's a big cylinder. That's the same size diameter as all the axial rotor combines that are running around out there. So a lot of capacity there. Actually, from a capacity standpoint, when we went on the standard chassis, so our class 6 and 7, the 7400 and the 7500, because we went to that 6-inch longer concave, larger diameter cylinders, the threshing area of a 74 and 7500 is only about 30 less square inches than a 760 or 780. So that standard chassis combine, class 6 or 7, has basically the same threshing area as the 760, 770s, or 780s had. So that's how much capacity we've gained just by going to larger cylinders. So quite a bit. For those in here with 700 series, we still have the V plates. That makes that material pass more efficiently in the rotors. We don't need that on the new combines, but if you got a 700 series, I still talk about those periodically. When folks get into really tough conditions, we still offer the V plates. So, any questions on threshing? Here's the impeller that is inside this combine and all other 8,000 and 7,000 series, and this is what you came from before, right here. So this is 24 inches in diameter, the same diameter as the yellow combine threshing cylinder. It has staggered paddles on it that's going to grab that material very much similar to the APS cylinder. And we know that the APS cylinder up front optimizes that crop flow as it exits the feeder house. So whatever the condition of the crop is in the feeder house, the APS cylinder is going to rearrange it and feed it the way the threshing cylinder wants it. So it's going to take the romping sound out. It's going to smooth those hot spots out, take the romping sound away. This one's going to do basically the same thing. Once it's behind the threshing cylinder, it's going to optimize that crop flow and push it into the rotors. But when it goes into the rotors, it's going to go on the bottom side of the rotors now, not straight into the rotors like we did with the 700 series. It's going to go uphill, so it's going to thread that crop right into the flighting on the fronts of the rotors to really improve the feeding efficiency going into the rotors. So that's going to put less wear and tear on both crop and combine, and it's going to cut down on any of that material that might have come back up over the top, resulting in much higher grain quality as a result of that, just by the changes that we did in there. So we lowered the floor, we changed the angle of the rotors, opened this area up right underneath here to allow that crop to slide up underneath the rotors and thread in versus more of that straight on shot we did before. So that really improved a lot of the efficiency on the combine just in that transition area between the threshing and the separation. So looks very similar, doesn't it? Some folks may have had something similar put in their 700 series. So, but very heavy duty. So, moving back to the rotors, now we've got more rotor cover plates on these combines if you choose to get them. We have a feature called 4D cleaning. Did anybody get 4D cleaning in here? Okay. So that'll keep things a little easier. What 4D cleaning does is it leverages the rotor cover plates to counter the side roll of the combine. So if the combine leans to the right, those rotor cover plates are going to pitch the grain to the high side of the machine so that the crop doesn't drift down low and overload the low side of both the rotary turns pan and ultimately the upper sieve. So it really enhances the 3D cleaning feature on the combine. But really the big advantage of having the rotor cover plates is all corn models come standard with two. So the first two grates on each rotor come standard with the rotor cover plates. Now the advantage of rotor cover plates are similar to transport vanes used by other combines where they flatten them out to slow the crop flow relative to rotor speed. But that puts a lot of drag on the crop and the combine and burns more fuel. So what we want to do is we just want to hold the crop in there, but we don't want to put any more drag on it. So we put these on the outside, close it down, hold the crop in the cage longer. And as we do that, not only do we optimize separation, but we put more of a spin on that chaff and direct it more towards the back. So by closing the rotor cover plates, we will minimize the amount of chaff that goes down to the upper sieve because we put more of a spin on it and force more of it to go to the chopper and reduce the amount that goes down to the cleaning shoe. So that helps out not only the upper sieve cleaning performance, it reduces the amount of returns that the combine will have as well by utilizing the rotor cover plates, by closing the front two off. So in beans and wheat, I'll usually start with both of them closed if I'm setting the combine manually. Now if you're using CMOS automatic, it'll determine when it needs to close those rotor cover plates and do so automatically as it travels through the field as it tests the different settings based on the changes in the characteristics of the crop coming in the combine. So you'll watch that on the screen, watch those periodically open or close. But manually, I'll usually start in beans with at least the first one closed, very dry, chaff-heavy beans, maybe both closed. Wheat, I'll close both of them up for wheat around here. Unless it's high moisture wheat, then I'll have them open. So, but otherwise, it's a great tool to have. Another convenient feature, much like the disawning plates. They are very effective at controlling the chaff load that goes down to the sieve. So why let that go to the shoe when you can force more of it out the back? And that's what these really help do. So controlled right from the back right corner of the cab, or like I said, automatically as you travel through the field. So any questions on these? I'll show you an easy way to determine how many cover plates you have on your combine just by looking on the side of the machine if you're unsure about how many are in there. So this one I know has 2 on each rotor. So moving from separation into cleaning, prep pans. We talk a lot about these every year. It's the same prep pans in this combine as it was the yellow combine. So some of the same maintenance points or housekeeping items apply. The number one is keep them clean and keep them so they'll move in and out. So you can slide them in and out of there. Just don't leave them in there and never take them out because it's kind of a challenge to get them out of there if you let the residue build up along the sides of them and wedge them in there. So it's good to exercise them, especially if you're growing seed beans. This is a great way to clean out your combine in seed beans, seed wheat, or just for storage over winter. By pulling them out of there, one thing that I'll do is, you know, I've always said spray grease up in here once you clean them off. Go ahead and keep doing that, but you might take a wheel grinder and just buzz the rough edge off of them along the side. That way you don't have as much contact with rough plastic along the side. Just clean the edges of them off. That way they'll slide up in there a little easier, but still spray some grease on there. That keeps that starchy residue from setting up and keeping you from getting them out of there. They're very easy to get out right under the rock trap. A great tool. I mean, there's no bearings, there's no augers you got to take care of. It's just you just got the 4 or 5 segments that slide right out the front of the combine. And again, really cuts down on the amount of time needed to clean the combine out when you're trying to go from one seed crop to another. So keep that grain sample pure in the grain tank. So I've seen them in various conditions, loaded up with dirt and debris this thick. I don't know how, actually you can see later on the fields where they harvested with that, because the crop just pours out the back if those have any buildup on them. So just watch it. Most of the time in corn and soybeans, it's unless you're harvesting in a lot of mud, we shouldn't have much of a problem around here. Maybe early on when doing green stem soybeans, you might get some sap down in here that merges with some dust and debris, but just pull them out of there and blow them off or hose them off, and that's all you got to do. They're pretty tough, made out of UHMW, the same material that skid plates under flex heads are made out of. So moving back onto the cleaning system. And I've already had questions about this year. A lot of folks like to crank the fans on Lexion combines, 12, 1300, 1400 RPM. Just remember that these generate a lot more pressure per RPM than a scroll type fan. If you're new to a Lexion combine, we don't have to use as much air. The last yesterday cutting wheat up in Michigan, running around 980 with a 45-foot head and 100 bushel wheat that was running about 12 to 13% moisture. So 980 to 1,000. CMOS was running, and CMOS had it dialed down to 980. And between 980 and 1,000, I don't think I saw it go much over 1,100 in probably more than 2 or 3 times. So it kept it down below that. And it used more of the upper sieve. Tighten it up a little bit more, use less air. You'll do a better job that way. Cleaner sample, more capacity. So when we get out there in the fields, kind of watch your loss monitors. It loads in at 65% sensitivity on cleaning and separation. I often bump that up to about 80, just because I want to know exactly where the loss is coming from very quickly, so that I can get it set faster. So if you're wanting to set it manually, I'd recommend bumping up your loss sensors a little bit more, get them a little bit more sensitive so you know exactly where the loss is coming from quicker. And then after that, adjust your fan speed, and those loss sensors will tell you if you got too much speed back there. It's really that balancing act between your throughput or your ground speed and throughput, the condition of the crop, how dry it is, how damp it is, where you find that sweet spot. But oftentimes it's a little bit slower than what you might think. It's not always that 1400 and just let it ride. Watch CMOS. When CMOS runs through the field, CMOS is always monitoring the characteristics of the crop that's going into the combine and going into learning mode and learning different optimal ranges of settings, and you'll just watch that how it manages fan speed, where it's all too easy for us to crank the fan. Well, CMOS likes to balance that sieve and that fan speed down to do a better job, more efficient job of cleaning. So CMOS is a great tool to use when just trying to set the combine, but more importantly, just let it go and keep that combine completely optimized all the time. So that'll be something that's in one of the handouts that you'll be emailed, is how to set up your CMOS automatic. The new software in the green combines, the 8000 and 7000 series, is a lot higher performing, a lot more accurate than what we've had on the yellow ones in the past. So it's gotten a lot smarter. So bump back into the upper sieve area. For those wondering, the standard sieves in these now are the upper sieve is the deep tooth upper, and the lower sieve, standard lower sieve, is now the CB22. And we've had that for the last couple years now, especially with CMOS automatic. We needed to have a bottom sieve that did a little better job cleaning. It was great having all that corn capacity with the deep tooth lower, but we were struggling a little bit with cleaning. So we went with the CB22, which basically is a deep tooth corn sieve that we raised the webbing up on. So you can see that there. So basically it would have been a deep tooth, but we raised that webbing up, and you end up with results that look like that. So deep tooth on the right, CB22 on the left. That deep tooth on the right would have been set to 0. That was set to about 5. And you can see it's much cleaner than the deep tooth set to 0. So both of them do equally as well in corn. So this one you might stand that one up just a little bit more in corn, but cleaning wise, they both do the same job in both throughput and cleanliness in the grain tank. You just got the advantage of getting that grain tank much cleaner in beans and wheat than we had before when we had to run these at 0. You always got pods or some tips of the head escaping through those when they were at 0. And got a few complaints over that, so that's where the CB22 came from. And that can go into any combine that's got jet stream cleaning on the bottom sieve. We just run it in the bottom, not on the top. We keep the deep tooth upper on top. So haven't had any problems with it. So, anybody put that in their yellow combine, the CB22? Notice the advantages of it?
Liked it in beans.
Like bean, yeah. Corn, you're probably not going to notice much.
High
But
moisture corn, I didn't get along real well with it.
did you have to stand it wide open?
Yes, and eventually put the deep tooth
Back in for a while? Yeah, high moisture corn. I mean, some folks take the
20
bottom.
plus corn.
Well, some folks will take the bottom sieves completely out in high moisture corn, and we offer kits for that too. So if you want to take your bottom sieve completely out in high moisture corn, we have covers that go over the returns, so you don't get any returns in there. Just fill her up and not worry about returning anything. So, and I've also, in your handout, you'll get all the lists of all the part numbers for all these different sieve types, APS grates that you might need down the road. This is the advanced chopper, so very similar to the turbo chop, but has been refined from the previous turbo chop. We don't have the electric motors in here anymore. They're hydraulic cylinders. So that's going to allow those center deflectors to compensate for side wind and side roll of the combine. You can see the wind deflectors that are back there on the back of that combine right now that allow these center deflectors to move according to the wind speed and direction or the roll of the combine. They'll either go out and in together or left to right as needed to blow more into the wind or uphill. So that's the big change there. All completely controlled from the cab. So you can adjust everything from the cab. It still has some lever operated functions, standard if you want them, or else you can have all your stationary knives, your friction plate, all done completely from the cab, as well as your high and low from the cab. So and this one's got all those features on it that we'll look at. The advanced, or the premium chopper, which will in the future be taking the place of the advanced chopper. We're going to discontinue that chopper after this year for this one. And the reason why heads are getting bigger. We're already at 45. It sounds like there may be some 50s coming down the road. MacDon's got one coming, so we need something that's going to have a little bit more throwing power, and we need something that's got more action to it. And so that's where this premium chopper. We've been using this chopper in small grains very successfully for several years now. We brought this out back in when the first 700 series came out, worked very well there. The last few years we've been adapting it and following it very closely in corn. It was very successful. We knew it was going to work in soybeans. We wanted to make sure it was going to work very well in corn, and so far so good in corn. It hasn't proved us wrong yet. The difference between this chopper and this chopper, I mean, fundamentally they're very similar. Same tailboard, similar spreaders, except this one doesn't have the paddles, it's got the cast fingers on it. But what separates the two are these radial arms you see right here. So there's the center of each spreader, and there's an arm that they're both dialed in like this right now. So what those do is when we're chopping, they're sitting there oscillating around the circumference of those spreaders. And as they do that, what they're doing is they're basically pressurizing that material. It's like putting your thumb on a garden hose, and it pulses that material out the header width. And the operator can adjust the timing of that from the cab to nudge it further into further up closer to the standing crop, or further away or out of the standing crop as needed. So they can adjust all that from the cab. And what you're going to see out of the back of this, and this is something that the no-tillers and strip tillers really like, is it doesn't spray the material out the back. And sometimes when we spray straight out the back, everything remains in a kind of a linear pattern. And when it's in a linear pattern, it's rolling around and sometimes creates streaks out the back, which you don't want to no-till in or strip till into. So this disrupts that. And so what you'll see is it sits there and sprays the material out over the full header width behind the combine, giving it a different pattern. You might see a little bit of a sawtooth pattern along the edges of the field just as it sits there and sprays the material out, but you're not going to have those concentrated streams laying out behind the combine, because that's disrupted that and prevented that from happening. So you're going to get a much more consistent, even blanket of residue behind the combine. So that's something the no-tillers have really appreciated, is this new chopper. These fingers, however, if you do have this chopper or on combines, you can actually put these cast fingers on these choppers. There's an update kit that you can purchase that's got the fingers and the brackets. If you've had some issues in the past with the older series turbo choppers or the advanced chopper, you can put these on there and improve that streaking action. That was something we found out later once we got this straw chopper running for corn, that those work really well at disrupting the streaking as well on the back of the combine. So we do have that information that you can have as well. It's got all the part numbers and everything in it. So. Stationary knives, remember one thing, our combines have a lot of knives inside here. And one thing I always recommend doing is don't use all your stationary knife. For one reason, you're going to save power. I mean, it's great to sometimes turn all that material, pulverize all the material, but you got to remember, lighter material doesn't throw as far. So the more knife you use, the more challenge it might be to get it to go out farther. Larger particles fly farther than small particles do. So I'll usually start with my stationary knives only halfway in. If you want to turn everything to dust, you can do that. But I'll usually start with mine halfway in, or I recommend putting them halfway in. That's going to conserve power. Or later on in the season, as conditions dry out, a lot of customers have found and have told me they don't even use the stationary knives late in the season in soybeans. They pull them completely out, and it still pulverizes the stems. So play around with that. Don't be afraid not to do that, especially if it's controlled from the cab. Just try it. Pull them all the way out when you're doing soybeans and compare the performance. I think you'll find that, especially later in the season when conditions are dry, you don't need your stationary knives. You can pull them all the way out. And if you do want a little bit more aggressive chopping, pull those all the way out and engage your friction plate. Create that speed bump in there that tumbles that crop higher into the knives and gets more chopping action that way without having to have the blades mesh and have that resistance back there between the rotary knives and the stationary knives. So just something we've played with and experienced, especially with being able to control it all from the cab. So rather than getting out of the cab. So, and for those that have had combines in the field already last year, the year before, I've always got to bring up worn knives. This is the fastest moving feature on the combine next to the engine. So you want to make sure that your stationary knives and your rotary knives are in good shape. They don't look like a butter knife. If they look like a butter knife on the leading edge and you haven't flipped them, flip them over. They're going to take less power that way. You might be able to go into corn with them looking like that, but I sure wouldn't want to go into soybeans or damp wheat with my knives looking like this. So I'll flip these knives over and get that straight edge on the outside. And you'll have a much better job. Your percent engine load isn't going to climb nearly as quick or as far by doing that. when they start off fresh like that. And again, when you break one, the steering wheel is going to feel like what? Like you're holding what? Gas-powered weed eater. When you break one knife, that really high frequency vibration is going to go all the way to the cab. It's kind of an early warning detection, if you will. And if you break one, you got to change 8. Keep that balanced. So if you break one of the outside ones, change the one 180 degrees from it, and the ones on the other end of the drum, same with the middle. If you don't have any spares, pull those ones from the very outside and put them in the middle, or just take them out and run without them. But you got to keep it balanced. As fast as that running, you don't want any vibration back there on those chopper drums. So just a heads up on that. So, but there's a great storage device or compartment on this combine I'll show you where you can put about 8 knives or 10 knives or 12 knives. We'll show you that on here. So really handy. Also, you can store sickle guards, sickle sections, hardware, everything else on there. Nice little organized storage compartment. Yield monitor wise, we changed the way we tension the elevator. So we no longer have the hydraulic cylinder on the front side of the elevator, and for good reason. You folks will like this. We no longer use the light beam yield sensor. We have a mass flow sensor now up in the top of the elevator, just on the front side of the elevator. So as the crop exits the elevator, it comes into contact with the mass flow sensor and gives you your yield readout in the cab. We've had the calibration is the same as the volumetric, so it's very simple. It's just a batch load. And the accuracy so far that I've been seeing on them right now is they're coming out of the factory running about 2 to 2.5% off. So they're very accurate right out of the box. So that's on the last 2 that I was on. We calibrated them with scales on the cart, and they were only within like 2.5%. So that's very good right out of the box. So, and that's just using and then to get it calibrated, just using the same procedure we did with the volumetric system. So no more test weight. We don't have to do test weight because you're already accounting for that with the mass flow, the force that's being measured up here in the mass flow sensor. So you'll see it in CBIS where you can enter in the test weight, but just don't do that. That we still use that volumetric sensor in other markets around the world. And we still have to have that calibration or that setting in there. But for the mass flow sensor, we don't have to mess with test weight anymore. Just dump in the cart with scales, and then enter the amount in bushels on CBIS. So, and then the tensioner is very much the same as ag leader. So you got your draw bolt down the bottom of the elevator, so you loosen up your plate. You got your draw bolt on the bottom, so you pull from the bottom, pull the chain down, versus pushing up on the shaft like we used to, because we have to maintain that fixed gap up on the top between the paddle and the deflector plate, just like an ag leader system would. So, still the volumetric sensor inside the returns elevator like we've always had. So that still works very well in there. So I'm going to save the maintenance portion to over here on the combine. It's easier to look at on the combine than it is here. One other thing, dynamic power on the combine. This is a new feature on these machines. What dynamic power is it optimizes your engine load to conserve power. And it will shoot right back up as soon as it senses a load on the engine. You got 10 different power curves right here. So if it's not using the power, it's going to reduce the amount of fuel to lower the horsepower of the combine until needed. So with dynamic power on, and you unload on the go, or it senses a sudden load, it's going to go right back to maximum power as soon as it senses that. And that's really been helping us out on our fuel consumption. I know that's not always a priority to many folks, but every little bit helps. And this has proven to be very effective in managing the power on the combine, especially when trying to save every little bit of dollars we can, even in fuel consumption. But it's not something that limits power. It's something that makes sure that you always have maximum power when needed, when you've got this set, when it's turned on. You can run with it off, or you can run with it on. And most folks notice when they're running with it on, that they're saving a little bit more on fuel doing so. Not filling that fuel tank up nearly as often when they run with that on. So that's not on the yellow combines, that's only new on these combines here with the Mercedes and MAN engines. So the rest of my presentation is on maintenance, and we'll talk about that around the combine. So we'll go ahead and take a break, and we'll meet up back at the combine.